Last class, we looked at Boyle's law and saw that at constant temperature, volume and pressure were inversely related. Today, we're going to be talking about Charles's law. If you would like, go ahead and pause this video and open up the guided notes to follow along for this class. So Charles's law discusses the properties of gases at constant pressure. If we are at constant pressure and we increase temperature, then the rate of collisions between the gas particles are going to increase. This means that the collisions are more energetic. In order to maintain a constant pressure, then volume will have to increase as well to compensate for those changes. This means that volume and temperature have a direct relationship. As volume increases, temperature increases as well. In this image, we see that as temperature increases, the volume of our gas increases as well in order to maintain the same pressure between our gas particles. So the equation for Charles's law is going to be V1, volume 1, divided by T1, temperature 1. This equals to V2, our second volume, over T2, our second temperature. Here are some everyday examples of Charles's law at work. Let's think about the tires on your car. Many of you are new drivers and may have noticed that you have to add air into your tires during the winter months. That's because as the temperature decreases, the volume of gas inside of your tires decrease as well. What about a hot air balloon? Gas is heated by a burner inside of a hot air balloon. When it is heated, the gas expands and takes up more volume. This provides the lift for the hot air balloon. And what about baking a bread? So carbon dioxide is actually released by the yeast inside of your bread. As the bread bakes, its temperature increases. The carbon dioxide molecules will expand, leaving you with fluffy bread. Reminder, when we do gas law calculations in our class, we will use temperature in units of kelvins. A balloon is filled with helium gas and has a volume of 275 milliliters at a temperature of 303 Kelvin. What would the volume be in milliliters if the temperature was reduced to -5 degrees Celsius at constant pressure? So this question notes that pressure is constant. Therefore, we're going to be using Charles's law, and that means we'll use the equation V1 over T1 equals to V2 over T2. We're given the value of T2 in Celsius. Therefore, we must convert it to kelvins first before using Charles's law. So kelvins equals to Celsius plus 273. We can just plug in our value for T2, which is going to be the -5 degrees Celsius, and add 273 to it. Then we find out that -5 degrees Celsius is equal to 268 degrees Kelvin. Now we just plug in all of our known values and solve for V2. Our initial volume is 275 milliliters, so that's our V1. V1 is divided by our initial temperature, which is 303 Kelvin. This is equal to our unknown, V2, divided by our second temperature, which we just found to be 268 degrees Kelvin. Then we just perform some simple algebra and find that V2 is equal to 243 milliliters. So we find that as temperature decreases, volume also decreases. Today you're going to be cooking with Charles's law. Did you know that many baked goods, such as popovers, bread, muffins, etc., they all rely on Charles's law? The gas inside foods, such as popovers and popcorn, is mostly water vapor. The gas in bread is mostly carbon dioxide. So just think about how temperature and volume of gases are related to each other and how this produces the products we have. So choose any popover, bread, or popcorn recipe that sounds yummy to you. Take a picture of your dish before it goes in the oven and after it comes out of the oven. You're going to download the PDF file titled Charles's Law Recipe. Then go to your toolbar and click Launchpad. Here there's an icon called Preview. Open it and then select the downloaded file. Here you can edit using the marker icon. Click the text box and then just fill in your dish, chef name, recipe, etc. So you're going to fill in the dish name and recipe, include an image of your dish before and after it has come out of the oven, and then you're going to include a short statement on how Charles's law was used in your dish. What gas was primarily found in your dish? How did volume and temperature change? Did pressure change? Once you're done, just click File and Save. Then you're just going to save and upload your file onto OnCampus. Have fun!